In this video, I'll show you an example of consumer-driven contract testing from a provider perspective. In my practical case, the provider will be backend application based on Node.js and MongoDB. But generally, the stack of the provider is not very important because the verification process focuses on REST requests and responses. I'll use Pact.js to run the tests and verify the Pact contract. We also will consider some questions regarding preparing predefined states of the provider and authentication for testing purposes. We have a contract hosted on Pact Flow. This contract was generated by consumer and reflects its expectation regarding communication with provider. For this moment, the contract is not verified yet. To run Pact testing based on that contract, we need to use Pact Foundation dependency, which will give us required Pact.js functionality. And above in package.json, we see this command that executes a script and runs the Pact tests. This script is entry point of whole test process of provider. A main actor in the test script will be the verifier object. We are exporting the verifier class from the Pact Foundation package. Before running the test, we need to set up verification options, which also include access credentials to contract on Pact Flow. To retrieve the contract from the remote broker, we need to put a broker URL and access token, provider name and version. And in this point, we create a Pact verifier object with prepared options and run verification. In this scheme, we can see that the script sends credentials to the Pact broker and gets back the contract that was generated by consumer. The Pact broker hosted on the Pact Flow project, which also provides a web interface to view existing contracts and verification results. Let's consider this one interaction. We pass to the backend, which is a provider, the client ID, and return the changes relative to the client, which is a consumer. Here we can observe that we strict in what we send and liberal what we get, according postal law, also known as robustness principle. According to the contract, a verification mechanism will pass precise client ID value. But for the response body, Pact uses matching rules, instead strict comparison. That allows some variety of data and only types are important. So when the Pact verifier will start doing his work, it will send the real API request to the Node backend instance based on description of interaction from the contract. For our case, we have a GET request to this path with the client ID in the query string. And when we will get back a response, the verifier will check it based on matching rules from the contract. Let's look at the scheme. We see a backend node instance here that is a copy of a real backend app. The node server uses a test database. The test script with Pact verifier uses the contract to generate and send requests to the REST API and to verify responses. The result of verification go into the Pact flow and will be available via web interface. But to perform these tests successfully, we need to prepare special states of the provider. In the most common case, we need to feed a database with test data. Every title of interactions contains a state name after the keyword given. This is a unique identifier of state. Among Pact verifier options, there are state handlers. In fact, this is a set of hook functions that are bound with interaction test cases via state names. These functions are called according to a state name in the description of interaction under the test. And in the considering case, this is a state with name has changes relative to the client. In this practical case, this function puts in the database a user with client ID and two tasks. This is how it looks on the scheme. Before making a request to the REST API, the test script uses state handlers to put data to the test database. To make Node backend application able to successfully handle the request from the Pact verifier, it needs to pass the authentication stage. To achieve this, we must pretend that the request was sent by an authorized user. In the state handler, I add to the database a fake user that will play a role of authorized. The object that contains predefined user parameters is exposed in a separate file and can be accessed outside of the test script. After we added this user entity to the database, we also needed to mock an auth middleware to use the same predefined user object during the test request passing. Here is my router that uses authentication middleware. To substitute a real logic of the middleware function, I pass an auth mode parameter that can be equal to test or normal depending on the environment variable. In the middleware of function for the test case, I just attach the fake authenticated user to the request object, and in further, it will be used by program flow as a real user that passed authentication. The middleware of function uses the same predefined fake user as the test script does. A big difference between consumer testing and provider testing is that on the consumer side we use narrow unit testing that verifies communication between collaborators and external services. But on the provider side we use real requests to an actual application that goes through all layers from API endpoints to a repository. It looks a lot like functional testing, but it really isn't. During the functional testing, we verify that provider is doing the right things. Contract testing is about making sure your consumer team and provider team have a shared understanding of what the requests and responses will be in each possible scenario. In my practical case for a functional test, I would have to verify that I get a precise array of certain changes. And for contract testing, I just want to be sure that I have an array of objects that have the right type. Not important what exactly objects are contained in this array. So, if for some reason the main logic will be modified and a different array of objects of same type will be sent in response, the functional tests will be failed, but the contract tests will still be fine. To run the test, I build up on my local virtual machine separate Docker containers with a test database, a copy of Node application, and I run the test script itself in the third container. From terminal output, we know that the one test with a request to delete a task was failed. We can also check the results on Pact flow. Basically, we see the same information in a more pretty form. And here is a failed test. We got 404 not found for the delete request, instead 200 OK. And this makes sense because if you look into my routers, we see that I don't have a ready endpoint for this method. We can consider this as a practical usage of the test-driven development philosophy. We have consumer requirements for the provider and we prepared a test case for this. But till we do not implement these requirements yet, the test will be failed. Let's look at the general scheme of the CDC provider testing. We use a Pact broker hosted on Pact flow to share the contract. The test script uses a verifier object from Pact.js library to get the contract and perform the tests. The options of Pact verifier allow to prepare states of the test database for corresponding interactions. We mock authentication mechanism with a fake user to pass the auth stage. The test script sends requests to node instance of Backend and verifies responses according to the contract. The result of verification published on Pact flow and available via web interface. In this video, we considered CDC testing with Pact for provider. We used the contract to prepare provider states, send requests, and verify responses. And together with my previous video, in which this contract was created as a result of consumer testing, we have a full understanding about the whole cycle of consumer-driven contract testing.